Okay, we're back at it here. So we're on worksheet 3-5, and the last one we left off on, we did number 15, so we're on number 17 here. Okay, so I don't have my notes up here anymore, but hopefully you took notes. So we have -4 over x minus 2 squared. Okay, x minus 2 squared. So here's what we need to do. Okay, first off, our vertical asymptotes. For our vertical asymptotes, what makes the bottom 0? So what makes the bottom 0? 2. So at x equals 2, we draw our vertical asymptote. Okay, so the degree of the top, let's find our horizontal asymptote. The degree of the top is 0. The degree of the bottom is 2. I don't remember which case I had for cases A, B, and C. I might have mixed them up here. I don't remember which order I put them in. But since the degree of the top is less than the degree of the bottom, it's approaching the x-axis, okay? What it says in our notes, the degree of the top is less than the degree of the bottom, it approaches the x-axis, okay? So for our x-intercepts and our y-intercepts, got to get these. For our x-intercepts, plug in a 0 for y, okay? Or what makes the top 0? Nothing. There are no x-intercepts because it's always -4 on top. For our y-intercept, plug in a 0 for x. If I do that, I'll have -4 over 0 minus 2, which is -2 squared, which is 4. Y-intercept is -1. -4 over +4 is -1. So my y-intercept is -1. So it's right there, okay? We have two sections to the left and to the right. It's got to be down here because we've got to hit this point, all right? And it's either above or below here. There's no points and there's no intercepts that are formed if I put it here or here, so we got to do a test point. If I plug in 100, 100 minus 2 squared is positive. A negative over a positive is a negative, so it's got to be down here, okay? And that's what our graph looks like, okay? Let's look at number 19. Number 19, we have y equals x minus 3 over x. I'm not going to write x squared minus 1. I'm going to factor that. It's a difference of squares. That's x plus 1, x minus 1. Okay? So my vertical asymptotes are what makes the bottom 0. -1 we have a vertical asymptote. +1 we have a vertical asymptote. Okay? The degree of the top is 1. The degree of the bottom, it was second degree. Second degree. It was x squared minus 1. So the degree of the top is less than the degree of the bottom. So it's going to approach the x-axis. Okay, looks sort of like that. There, and then we need to find our intercepts, our x-intercepts, and our y-intercepts. For the x-intercepts, we plug in a 0 for y, or what makes the top 0? Same thing. X-intercept is 3. So we have 1, 2, 3. We have it right on there. Again, that's a little bit different. It's actually touching the intercept. Or, I'm sorry, the asymptote. For the y-intercept, plug in 0 for x. Okay? If I plug in 0, I'm going to do the original one. This is x minus 3 over x squared minus 1. If I plug in 0 for x, we're going to have -3 over 0 squared minus 1 is -1. -3 over -1 is +3. Okay, so my x-intercept is 3. My y-intercept is also +3. Okay, so here's what we got. All right. Over here, we got 3 areas. We got to the left, to the right, and in the middle. Okay, so this one, it's either above or below, and again, it could be either one of them because neither one of them are going to create any x-intercepts. All right, so if I was to plug in a big number like a -1,000,000, -1,000,000 minus 3 is negative. -1,000,000 squared is positive. -1 is still positive. A negative over a positive is a negative, so it's going to go like that. Okay, you don't have to use a million. You get like -100. -100 minus 3 is a negative. -100 squared is a positive, -1 is still positive, and negative over positive is still negative. Okay, let's go here in the middle. This one right here, well, I mean, it's got to be approaching both this asymptote and that asymptote. So it could either be kind of a parabola opening up or a parabola opening down, or it could be kind of S-shaped. It can't be S-shaped though, because if it's S-shaped, it's going to hit the x-axis again. Either way, it can't go like this because it's going to hit the x-axis again. Like this is going to hit it. So it's got to be a parabola. And it can't be a parabola opening down because then it's going to hit the x-axis twice. And it's not going to hit it any more times. So it's got to be a parabola opening up. Okay? Now this is weird because this one's right on the border. It's right on the asymptote between the top and the bottom. Okay? So here's what we need to do. Okay? Remember, it can touch a horizontal asymptote, just not a vertical asymptote. We need to pick a number between 1 and 3 to find out where this thing is. Is it going up like this or is it going down? I don't know. So if I was to plug in 2, okay, this is 1, this is 2, this is 3, let's plug in 2. If I plug in 2, 2 minus 3 is -1. And if I plug in 2 right here, 2 squared is 4, minus 1 is 3. Negative 1/3. So at 2, we're at negative 1/3. So it's got to be down here somewhere. So it's got to be going like this. Okay? Now, here's the deal. It doesn't bounce. Okay? It's not raised. So it has to cross over. And then what happens is this. It's got to approach this. So what happens is it's going to go up some. Okay? But then it's got to swing back around. And it's going to come very, very close to it. And it doesn't cross it because that would create another x-intercept. All right? So it looks, that's kind of a weird looking graph, but that's what it looks like. Okay? Let's try a few more. 21. All right, what's number 21 say? We have, okay, 21, we have y equals, I'm going to factor this, take out a 2, 2 times x squared minus x minus 2 over, I can factor this, x squared is x and x. Last term's negative, so plus and minus. How do we times to get negative 12, but add to positive 1, positive 4, and negative 3. The top factors further, I believe. Yes, it does. So we have 2, that looks terrible, x and x, plus and minus. How do we times to negative 2 and add to negative 1? Negative 2 and positive 1 over x plus 4, x minus 3. Okay, we factored all over the place. Lots of factoring here, okay? So, if we do that, our vertical asymptotes, what makes 0 on bottom? Negative 4 and positive 3. Okay, back at the original one, what was it? It was 2x squared minus 2x minus 4 over x squared plus x minus 12. Okay, the degree of the top is 2, the degree of the bottom is 2. They're the same. So we take the lead coefficient, divide by the lead coefficient, 2 over 1, which is 2. So it's going to approach the line y equals 2. All right? Our x-intercepts and our y-intercepts. Okay, for our x-intercepts is what we plug in 0 for y, or what makes the top 0. The top is 0 if I plug in negative 1 or positive 2. So at negative 1 and at positive 2. Okay? My y-intercepts, you plug in a 0 for x. And I plug it into the original one. If I plug it in for the original one, anything with an x goes away. So we're left with negative 4 over negative 12. Negative over negative is positive. 4/12 is the same as 1/3. So positive 1/3, which is, here's 1, so positive 1/3, I don't write about there. Okay? And this is weird, because this is actually a pretty easy one to graph, actually. We have 3 areas, to the left, middle, and right. Okay? On the left, it's got to be up here, because if I go down here, it's going to create another x-intercept. So it's got to go up like this. Same thing here, it's got to go up. Otherwise, if it goes down, it's going to create another x-intercept. These are all below, so it's got to be below, so it's going to go like this and like that. Sort of like a parabola. Not exactly, because it's not symmetrical, okay? But it's sort of parabolic looking, okay? So that'll look pretty bad, but actually, once you get all the stuff in there, the graph itself isn't that bad. Let's try a few more. 23. Okay, so we have y equals, I'm going to write this now, negative x squared minus x plus 6 over x squared plus 3x minus 4. Okay, so we could factor out a negative here. Negative x squared plus x minus 6. On bottom, I could factor x and x, plus and minus, times to negative 4, add to positive 3. That'd be a positive 4 and a negative 1. This factors further. Negative x and x, times to negative 6, add to positive 1. That'd be a positive 3 and a negative 2. Over x plus 4, x minus 1. And again, we haven't said this yet in this video. There's no holes because we're not canceling anything off. Nothing cancels. So, to find our vertical asymptotes, what makes the bottom 0? Negative 4. What makes the top 0? Positive 1. Degree of the top is the same as degree of the bottom. Take the lead coefficient, divide by the lead coefficient. Negative 1 over 1 is negative 1. So at negative 1, we have our horizontal asymptote. Our x-intercepts and our y-intercepts. For our x-intercepts, we plug in 0 for y, or what makes the top 0? Negative 3 and positive 2. So negative 3, positive 2. And my y-intercepts, plug in a 0 for x. Plug in 0, all these x's go away. We're left with 6 over negative 4, which is the same as negative 3 over 2, which is negative 1.5. I'll make it negative 1.5. So negative 1. So negative 1.5 is right there. Okay? And again, this one hopefully isn't that hard to graph. There's 3 sections to the left, the middle, and the right. Let's do the right side first. It's got to be up here because that's where the dot is. Ooh, that was terrible. Hopefully your graph looks better than mine. It's either above or below. Well, if it's above, it's going to create another x-intercept, so it has to be below. And this one right here, we got to connect the dots, okay? And it's got to approach both of these, all right? So this thing doesn't bounce, nothing raised to an even power, so it's got to go up like this. And if I go up, it's going to make another x-intercept, so it's got to go like that. This is what I was talking about. You know, this is a very complicated looking function, but with this very minimal work, you can tell what this thing looks like. That would be next to impossible to graph without knowing this. I'm not saying these are easy, but you know, without these little tricks, there's no way to be able to know what this thing looks like. Okay, so let's try hopefully 4 more, 25. So we have y equals, I'm going to write the problem down, 3x squared minus 3x minus 36 over x squared plus x minus 2. So let's factor this thing. We take a 3 out, so we have x squared minus x minus 12. This factors to x and x. Last it's negative, so plus minus, times the negative 2, add to 1, positive 2, negative 1. The top factors further. X squared is x and x, plus and minus because it's negative, times the negative 12, add to negative 1, negative 4 and positive 3, over x plus 2, x minus 1. Okay? Once we factored it, it makes it a whole lot easier. My vertical asymptotes, what makes the bottom 0? Negative 2 and positive 1. Degree of the top is the same as degree of the bottom, so take the lead coefficient, divide by the lead coefficient, 3 over 1 is 3. Okay, x-intercepts, y-intercepts, x-intercepts, plug in a 0 for y, or what makes the top 0? Negative 3 and positive 4. So we plot negative 3, and 2, 3, 4, positive 4, we have those two dots. Our y-intercept, plug in 0 for all these x's, we plug them in, they all go away except for negative 36 over negative 2, which is a positive 18. Negative over negative is positive, 36 divided by 2 is 18. So our y-intercept is positive 18. That's way the heck up here somewhere, okay? That's 3, so it's way up here. I don't want to get into the work here, though. So this dot has to go through this dot, so it's got to go like this. Oop, hit the dot. It's got to hit this dot, so it's got to go like that and hit the dot. And since the dot's up here, okay, it could either be a parabola opening down, that's no good, it's going to create x-intercepts, okay, or S-shaped, it's going to create x-intercepts. It's got to be sort of like a parabola going up. It's got to go away from the x-axis, okay? All right, 3 more. Okay, number 27. So we have f of x or y equals, I'm going to write it down, negative 2x squared plus 10x. 10x minus 12 over x squared plus x. All right, let's factor this thing. So we can take out a negative 2 times x squared minus 5x plus 6. I can take an x out, x plus 1. This factors further, x and x, positive, so either plus plus or minus minus. We've got to get some negatives, so minus minus times the 6, add to 5, 3 and 2 over x, x plus 1. All right, so my vertical asymptotes, what makes the bottom 0? Negative 1 and 0. So right there on the y-axis. So those are pretty tight in there. And the degree of the top is the same as the degree of the bottom. Take the lead coefficient here, negative 2 over positive 1, which is negative 2. So at negative 2, we have our horizontal asymptote. So we have 3 areas, the left, the right, and that little teeny part right there in the middle. Okay, let's find our x and y intercepts. Hopefully it feels like we're doing the same problem over and over, because we basically are. Okay, x-intercepts, plug in a 0 for y, or what makes the top 0? Top is 0, and I plug in 3 or 2. X-intercepts are 3 and 2. Okay, my y-intercept is plug in 0 for all these x's. If I plug in 0 for all the x's, you can't actually plug in 0 for the x's, because if you do, you're going to 0 on bottom. There is no y-intercept. Okay, which makes sense because we have an asymptote. Okay, if there's an asymptote, you can't have it on a vertical asymptote. Okay, so we got 3 areas, the left, the right, and the middle. Okay, let's do the left part first. It can't go like this because that would make another x-intercept. So it's got to go like that. All right, it's either got to be above or below. Well, again, it can't be an S shape because it's going to create an x-intercept. Okay, so it's got to be down here, and it's got to be sort of a parabola opening down. So if it's opening up, it would create x-intercept. So it's got to go sort of like that. Some sort of parabola in there. and then this. Okay, these are right next to each other, so I'm not sure what's going on here. I need to pick a point between 0 and 2. I'm going to plug in 1. If I was to plug in 1, okay, if I was plugging 1, that's a negative. 1 minus 3 is negative. 1 minus 2 is negative. Negative times negative times negative is a negative. Plug in 1 here and here. That's 1, positive 1. And 1 plus 1 is 2, positive. A positive times positive is a positive. A negative over a positive is a negative. So at 1, it's negative. It's down here somewhere. So it's got to go like this, okay? Now, it doesn't bounce. Nothing's raised to an even power. So it's got to go up some, and it's got to swing back around here. And again, it doesn't bounce, so it's got to cut through. And it's got to approach this, so it's got to go sort of like that. Again, some weird-looking graphs. Okay? All right, 2 more to go, 29 and 31. I think these next couple are going to be a little bit easier, a little bit quicker, I think. Yep, 29 will be much quicker. Okay, so we have y equals x minus 1 over x3 minus 4x. So if we do that, we can factor this x minus 1 over, I can take an x out, x times x squared minus 4, and that factors further, that's a difference of squares, so x times x plus 2, x minus 2. Okay, so what do we have here? What makes the bottom 0, 0, negative 2, and positive 2. So we have 4 sections this time. We have 3 asymptotes. We have 4 sections. The left, the right, the left middle, and the right middle. Okay? So the degree of the top is smaller than the degree of the bottom, so it's going to approach the x-axis. Okay? Our x-intercept and our y-intercept. Well, the x-intercept, plug in a 0 for y. What makes the top 0? 1 makes the top 0. Y-intercept, plug in 0 for these x's. You can't plug in 0 for the x's because it's an asymptote anyhow. So your x-intercept is positive 1. Okay? So what we need to do, again, it can be above or below. I don't know. If I pick a number like negative 100, negative 100 minus 1 is negative. Negative 100 is negative. Negative 100 plus 2 is negative. Negative 100 minus 2 is negative. A negative times negative times negative is a negative. A negative over negative is a positive, so it's going to be up here because it's positive. If I was to plug in a positive 100, 100 minus 1 is positive, 100 is positive, 100 plus 2 is positive, 100 minus, everything's positive, so it's also going to go like this. Okay? This one right here, it's got to be a parabola either opening up like this or a parabola opening down like that. Otherwise, if it's S-shaped, it's going to create another x-intercept. So I don't know if it's up here or down here. So we plug in a number between 0 and negative 2. I'm going to plug in negative 1. If I plug in negative 1, that's going to be a negative. Negative 1 is a negative. Negative 1 plus 2 is a positive. Negative 1 minus 2 is a negative. A negative times positive is a negative. Times a negative is a positive. A negative over positive is negative. So when I plug in negative 1, it's negative, so it's got to be down here somewhere. So it's got to be some sort of parabola opening down, so it doesn't create any other x-intercepts. Okay? Now this one could either be, it can't be a parabola, because it doesn't bounce. Nothing's raised to even power. So it's either going to go like this, or it's got to go like that. It's not a parabola. It's got to go through that point. All right? So I got to find out what's happening between 0 and 1. I'm going to plug in a half. If I plug in a half minus 1 is a negative. A half is positive. A half plus 2 is a positive. A half minus 2 is a negative. A positive times positive is a positive, times a negative is a negative. A negative over negative is a positive. So at a half, it's positive, so it's up here somewhere. So it's got to go like this, and it doesn't bounce, so it goes like that. Okay? You might want to pause that one and hit the rewind and watch it again, because that one's, I don't know, a little bit tricky. All right, is there one more to go? 29, 31. 31 is as far as we're going to go on this for at least right now. I don't know if we're going to do any of the others, like 33 or 35 later we'll talk about. They talk about oblique asymptotes. We may talk about that on Thursday. We'll see. Negative 3x squared over x squared plus 1. Okay, this is an interesting one. So, this, you might be thinking, oh, that factors, those are both squares. It's a sum of squares. It's not a difference of squares. So that doesn't factor, okay? So, my vertical asymptotes, okay, what makes the bottom 0? Nothing. When you square a number other than 0, if I take a positive number and square it, you get a positive, plus 1, which is still positive. I want 0. If I take a negative number and square it, it's a positive. Plus 1 is still positive. I want 0. I don't want a positive number. If I plug in 0, 0 squared plus 1 is positive. This is always positive, okay? There is no vertical asymptotes. There are no vertical asymptotes. A horizontal asymptote, well, the horizontal asymptote, the degree of the top is the same as the degree of the bottom, so you take negative 3 over 1. So your horizontal asymptote is negative 3. All right, for my x-intercepts and my y-intercepts, x-intercepts, plug in 0 for y, or what makes the top 0? 0. For y-intercepts, plug in 0 for x's. If I plug in 0 for x, that's 0 over 1, which is 0. So both my x and y-intercept is 0. Okay? And it's got to approach this horizontal asymptote. Now some students go, well, it goes like this. Well, it's got to have a curvature to it. That's like, you can't go like this, because there's curves here and curves here, but it comes to like a point. It looks more like, I would call it more like a hat. Looks like this. It's got to have curvature to it. Looks sort of like that. Okay? All right. Are we still going, I hope? Yes, we are. All right. Good luck, guys. I'll be back Thursday.